Hello everyone, welcome back to our channel gsipucmysuru. This is the second session of the 6th chapter, that is oscillators, from our second PUC electronics syllabus. In the last class we studied what is the meaning of oscillator, and also we derived an expression for the gain of a positive feedback oscillator circuit, and we also saw the two criteria, that is Borkhausen's criteria, depending upon which we can easily produce the sustained oscillations. So two criteria anta helidaga, the overall phase shift must be equal to 0 degree or 360 degree, that is the first criteria. Second criteria anta helidaga, the magnitude of the product of open loop gain, that is A, into the gain of a feedback amplifier, that is beta, must be equal to unity, that is must be equal to 1 anta nodidvi. So when we are going to satisfy these two criteria, then we will be able to generate or we will be able to produce a sinusoidal signals or a sustained oscillations anta helbodu. So oscillator is nothing but a circuit which produces the electrical oscillations anta nodidvi. So in an oscillator circuit, when we are going to satisfy these two Borkhausen's criteria, then only for a short duration of time we need to apply the input. Once the circuit has picked up, that is once the oscillations has begun, then the input can be removed completely. That we are going to understand with today's session, that is today's topic, what is called as tank circuit. So tank circuit is nothing but a circuit or an electrical circuit which produces electrical oscillations of any desired frequency. It's called as an oscillatory circuit or simply a tank circuit. So this tank circuit consists of capacitor and an inductor which are connected in parallel. So let us consider that we are having a capacitor C which is connected in parallel to the inductor L through a two-way plug switch to a voltage source which is denoted by V. This is a two-way plug key which is named as A, P and B. So when the P is connected to A, then the voltage source and the capacitor will form one complete circuit. So this is one complete circuit or one closed circuit. So as soon as the voltage source is turned on, the capacitor gets charged to the potential of V. Whatever the voltage I am applying, that voltage will be charging the capacitor C. So since the current flows in this particular direction, the upper plate of the capacitor will be charged to the positive potential, whereas the lower plate of the capacitor will be charged to the negative potential. As soon as all the potential of this voltage source is transferred to the capacitor, we are going to change the plug key to B, that is PA now will be changing to PB. Now the capacitor and the inductor will form one complete circuit. Here the capacitor is charged to the potential V, where the upper plate is charged to the positive potential, whereas the lower plate is charged to negative potential. Upper plate is charged to positive potential anta helidaga, there is the deficiency of electrons which are present on the upper plate of the capacitor. Adre illi lower plate nalli there are a more number of electrons which are present in the lower plate. So what happens is, as soon as we remove this voltage source and as soon as P is connected to B, these excess number of electrons which are present on the lower plate, they start moving towards its original place, that is towards the upper plate. Upper plate ke move aagake shuru agate. Here the electrons are moving anta helidaga, obviously there will be the flow of current because the electrons are moving from the lower plate towards the positive plate in order to become neutralized. So since electrons are moving in this particular direction, the current will flow in this particular direction. Because the flow of electrons and the conventional current flow is opposite to each other. So since the electrons are moving in this particular direction, the current flows in this direction. So this current will not increase all of a sudden, or this current will not increase instantly. It gradually increases. So this gradual increase in current flows through the inductor or flows through the coil. So we know that whenever there is change in current in a coil, there is a formation of magnetic field, or there is a formation of magnetic energy across the coil. So in this inductor, there is a formation of back EMF which helps in flowing the current further but in the same direction. According to the Lenz's law, the back EMF which is produced because of the change in the current through the inductor, that back EMF will try to oppose the flow of current, but once when the electrostatic energy is completely changed into magnetic energy, that is, capacitor will discharge through the inductor. Now inductor nalli maximum energy ide, the energy across the capacitor is equal to 0. So yavaga illi maximum energy reach agitto, matte the inductor with the help of the back EMF current flow ಆಗಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ, ಅಗೇನ್ ಇನ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇಟ್ ಸೆಲ್ಫ್. ಮುಂಚೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರ್ತೋ ಅದೇ ಡೈರೆಕ್ಷನಲ್ಲಿ ಕರೆಂಟ್ ವಿಲ್ ಫ್ಲೋ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಲೆನ್ಸ್ ಲಾ. ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಂತ ಹೇಳಿದಾಗ ನನಗೆ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನಲ್ಲೇ ಇದೆ. ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಹಿಯರ್ ರೆಫರ್ಸ್ ಟು ಪಾಸಿಟಿವ್ ಆರ್ ನೆಗೆಟಿವ್ ವೇವ್ ಫಾರ್ಮ್. ಹಿಯರ್ ಇನ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಂತ ಹೇಳಿದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದ್ದಿದ್ದು ಮತ್ತೆ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಎಲ್ಲಿ ತನಕ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ, until all of the magnetic energy is converted back into electrostatic energy. Since the current is flowing in this particular direction, now the lower plate of the capacitor will be charged to the positive potential, whereas the upper plate of the capacitor will be charged to negative potential. So as soon as all of the energy is converted back into electrostatic energy, making that lower plate of the capacitor to be charged to the positive potential and the upper plate of the capacitor being charged to negative potential, ಏನಾಗುತ್ತೆ ಇವಾಗ ಮತ್ತೆ the electron starts moving back to its original position, that is upper plate ಇಂದ lower plate ಗೆ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ electrons flow ಆಗಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ. Since electrons are flowing in this direction, now the current will flow in the opposite direction. Now the electrons are moving in the opposite direction, so the current will move in the opposite direction. Now gradually the current will move in the opposite direction, converting again back the electrostatic energy into the magnetic energy. That is, the electrostatic energy which is being converted into magnetic energy helps in production of the current now in the opposite direction ಅಂತ ಹೇಳಿದಾಗ ನಮಗೆ ಈಗ ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಬರುತ್ತೆ. ಸೊ this exchange of magnetic energy into electrostatic energy and electrostatic energy into magnetic energy keeps on continuing, which helps in the generation of this oscillations of desired frequency. ಯಾವ frequency signal ಬೇಕೋ ಆ frequency signal generate ಮಾಡಬಹುದು with the help of these two main components, that is capacitor and the inductor, between which the energy will be transferred from capacitor to inductor and vice versa. Here the direction of current plays a major role. Direction of current ಒಂದ್ಸರಿ ಪೂರ್ತಿ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ, the other time it will be opposite to that of the previous part. So negative current ಕೂಡ ನನಗೆ ಫ್ಲೋ ಆಗುತ್ತೆ. So it will helps in generating a complete sustained oscillation of the desired frequency. So this is all about a tank circuit, which is very much important in order to generate the sustained oscillations. This is used in almost all of the electronic devices, which helps in generating the oscillation or the electrical oscillating signals. In this tank circuit, we are having inductor as well as the capacitor. In each cycle, there will be some amount of power loss through this capacitor and inductor, either in the form of radiation loss or the dielectric loss. Radiation loss occurs in the inductor and the dielectric loss occurs in the capacitor. So eventually, if this loss is not stopped, then the amplitude of signal or the amplitude of the oscillating signal what is generated will not be constant. It becomes 0 at some point of the time. That is, we will be getting the damped oscillation. But we don't want the damped oscillations, we want the undamped oscillation or the sustained oscillations. So these losses, that is the dielectric loss and the radiation loss, will be given externally with the help of an amplifier. So we will not be able to generate the oscillating signals only with the help of a tank circuit. With this tank circuit, we need to connect an amplifier circuit which helps in coping up the power loss which occurs because of these capacitors as well as inductors in the form of dielectric loss and the radiation loss. Clear? Now we will move on to the next topic, what is called as LC oscillators. These LC oscillators, the name itself specifies, we are going to use two components, one is L, the other one is C. L is nothing but an inductor and C is nothing but the capacitor. These LC oscillators are further classified into two types. One is the Hartley oscillator and the Colpitts oscillator. Depending upon from which component we are taking the feedback to the amplifier, we are going to classify these LC oscillators as Hartley oscillator and the Colpitts oscillator. In the very first session of this chapter, while deriving the expression for the gain of a positive feedback oscillator, we had used two oscillator circuit. One is the basic amplifier and the other one is the feedback amplifier. Howda? So the circuit was like this. The output of the feedback was given back to the basic amplifier. So here in the oscillator circuits, a portion of the output must be given back to the amplifier circuit. Just now I told you that for generating a sustained oscillation or for generating electrical oscillation, we need amplifier along with a tank circuit. So a combination of these two circuits will help in generating a sustained oscillations. So feedback amplifier anta heldaga, here we will be using two components, one is the inductor and the other one is the capacitor. From which component, either from the inductor or the capacitor, from which component I am giving a portion of the output back to the input, accordingly we are going to classify these LC oscillators as Hartley oscillators and Colpitts oscillators. Now let us see what is this Hartley oscillators. In this Hartley oscillator, we are going to take the feedback or we are going to give the feedback from the inductor. That is, we are going to use L and C as a tank circuit. From that tank circuit, we need to give back the feedback to the input and that feedback will be taken from the inductor. So in the Hartley oscillator, the feedback will be given to the inductor. So oscillator contains two different circuits. One is the amplifier circuit, the other one is a tank circuit. So here for an amplifier, we are going to use a transistor this is Re. Here we will be having a bypass capacitor. Let us name that as C. This is R1, R2 and this is RFC, that is radio frequency choke, that is plus VCC. Now here we will be having a coupling capacitor. Coupling capacitor is nothing but a capacitor which helps in connecting the output of one circuit as the input to the other circuit. Here we will be having a tank circuit where we are going to use two inductors and one capacitor which is connected in this manner. So a portion of the output will be given back to the input through this tank circuit. So this is the circuit what we are going to use in order to generate the oscillation. This is V0 and here we will be getting the sustained oscillation of desired frequency. These two are the coupling capacitor. So this is a simple circuit where we are going to use an NPN transistor in order to generate the oscillations of desired frequency. So CC are nothing but the coupling capacitor, CE are the bypass capacitor, R1, R2 and RE are used to DC bias the transistor. RFC is nothing but the radio frequency choke which acts as short circuit for DC and open circuit for AC. That is, it helps in isolating the power supply from the collector of the transistor. And this is a tank circuit where we will be using two inductors which are named as L1 and L2, and this is a capacitor which is named as C. So this is a tank circuit and this is an amplifier circuit. As I have already told you, in order to generate electrical oscillation, we need two separate circuits. One is the amplifier circuit, the other one is the tank circuit. Now let us try to understand how does this Hartley oscillator work. As soon as the power supply, DC power supply is turned on, the current across the collector keeps on increasing, which helps in charging the capacitor. Here two inductors are connected in series where the central part is grounded. So these two will be always opposite in phase with each other. So the collector of the transistor will help in charging the capacitor. Once when the capacitor has charged to its fullest, the capacitor starts discharging through these two inductors L1 and L2. The potential across these inductor L2 is given back as feedback to the amplifier circuit, and the output of this oscillator circuit is taken from this L1. So this amplifier circuit will provide a phase shift of 180 degree and this tank circuit will again provide a phase shift of 180 degree. So totally 180 plus 180 gives me 360 degree, which is the very important criteria in order to generate the sustained oscillations. So according to Barkhasen's criteria, we have to make sure that the overall phase shift is 360 degree. So this amplifier will produce a phase shift of 180 degree, whereas this tank circuit will produce a phase shift of 180 degree. So totally we will be having a 360 degree overall phase shift. So like this, the Hartley oscillator works where the capacitor and these two inductors are playing a major role. This is a tank circuit. The capacitor will continuously charge and discharge through the inductors, which helps in generating the sustained oscillations. That is, the electrostatic energy of the capacitor will be converted into the magnetic energy, and that magnetic energy will be again converted back into electrostatic energy, as we have already seen in the last topic, that is the tank circuit. Clear? The frequency of this Hartley oscillator will be given by 1 divided by 2 pi root LC, where L is nothing but L1 plus L2. Here the feedback, as we had seen in the basic oscillator circuit, here we are having a basic amplifier and here we are having a feedback amplifier. So here the feedback amplifier was having a gain of beta and the output voltage was named as V0. Here it was this is Vf and this is V0. So beta is equal to output divided by input, that is Vf divided by V0. The same thing applies here. So the feedback is nothing but Vf divided by V0, that is the potential from which we are taking the feedback, that is through L2, and the output we are taking from L1. So Vf anta ಹೇಳಿದಾಗ I into XL1 divided by V0 anta ಹೇಳಿದಾಗ, sorry, this is XL2 I into XL1, but XL is equal to 2 pi FL and 2 pi F na, let me denote it as omega into L2 divided by I omega L1. These two gets cancelled. So the feedback factor will be calculated using this L2 divided by L1. So beta is equal to L2 divided by L1, and this beta is called as the feedback factor. If beta is equal to L2 by L1, we know that A into beta must be equal to 1. So if beta is equal to L2 divided by L1, this has to be satisfied, or this has to give me a value of 1 anta helidaga, what must be the A value? L1 divided by L2. So A value, that is the open loop gain, must be equal to L1 by L2. So by calculating this product, we are going to make sure that the second criteria of Barkhausens is satisfied in order to generate the sustained oscillations. So the first criteria is satisfied in this circuit by providing 180-degree phase shift from the amplifier circuit and another 180-degree phase shift from the tank circuit, and this, the second criteria, that is the product of, or the magnitude of the product of A and beta, must be equal to 1 anta helidaga, we are going to match that with the help of these values, that is A will be equal to L1 by L2 and beta, which is nothing but the feedback factor, is equal to L2 divided by L1. Clear? The frequency can be calculated using this formula. F is equal to 1 divided by 2 pi root LC, where L is equal to L1 plus L2. Clear? Now we will solve one simple problem on this topic. So this is the first problem in which a Hartley oscillator has L1 as 3 millihenry, L2 is given as 5 millihenry and C is given as 10 nanofarad. Determine the frequency of the oscillation. Here they have clearly mentioned it is an Hartley oscillator. So you can use this direct formula where F is equal to 1 divided by 2 pi root LC, where L is nothing but L1 plus L2. L1 value is given as 3 milli, L2 value is given as 5 milli. So L is equal to total milli 8 millihenry, that is the total of the sum of these two, which is equal to 8 millihenry. Let us substitute these values here and find out 1 divided by 2 pi root 8 milli, milli andre 10 to the power of minus 3 into C is 10 nanofarad. Nano stands for 10 to the power of minus 9. So 10 into 10 to the power of minus 9. In these problems, you have to make sure that the sum of these two powers, that is 10 to the power of minus 3, 10 to the power of minus 9 is equal to 10 to the power of minus 12. That is, it must be exactly double of any number. So minus 12 anta ide, so half of that is equal to 6. If this number is equal to 10 to the power of minus 11, add ಮಾಡಿದಾಗ 10 to the power of minus 11 ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ, you must convert either that to 10 to the power of minus 12 or convert that into 10 to the power of minus 10. 10 power minus 10 ಅಂತ ಹೇಳಿದಾಗ half of that is equal to 10 to the power of minus 5. 10 to the power of minus 12 anta helidag, half of that it is equal to 10 to the power of minus 6. Why I am telling this is, whenever you are going to take that number out of the square root, if it is exactly double of any number, then you can easily bring that number out of that square root. So 1 divided by 2 pi root 80 into 10 to the power of minus 12. So 1 divided by 2 into 3.14 into root of 80 gives me 8.944 into 10 to the power of minus 12 is in the within the bracket, within the square root. When it comes out of the square root, it is 10 to the power of minus 6. So let us multiply this. So this is equal to 56.168 into 10 to the power of minus 6. So 1 divided by this answer will give me 0.0178 into 10 to the power of minus 6 is in the denominator. When it goes to the numerator, it will become 10 to the power of plus 6 hertz. So frequency is this much, but let me convert this into kilohertz. So 0.0178 into 10 to the power of 6 anta ide alva. Now you need to convert this into 10 to the power of plus 3. So I have already discussed this in the class. 10 to the power of 0 ಇಲ್ಲಿ central ಇದೆ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ, in the normal graph what you are going to do, if you are going to consider this as the axis point or the 0 axis ಅಂತ ಹೇಳಿದ್ರೆ, to the right side you are going to write the positive values, to the left side you are going to write the negative values. But here, in order to convert these plus 6 in a plus 3 or minus 3 na minus 6 and vice versa, what you are going to do is, to the right of this 10 to the power of positive, 10 to the power of 0, you are going to write 10 power minus 1, 10 power minus 2, 10 power minus 3, and to the left of this 10 power plus 1, 10 power plus 2, 10 power plus 3. Here you need to convert this 10 to the power of plus 6 to 10 to the power of plus 3. Where is it? 10 to the power of plus 4, 5, and here 10 to the power of 6. 10 power 6 na 10 power 3 ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದರೆ you have to move towards the right. That is, point ಏನಿದೆ, you have to shift this point towards the right. How many times? 3 times. So 1, 2, 3, which is equal to 17.8 into 10 to the power of 3 hertz, or F is equal to 17.8 kilohertz ಅಂತ ಬರಿಬಹುದು. Clear? But suppose I was having 10 to the power of 5, ಇಲ್ಲಿ 10 power 5 ಇತ್ತು, 10 power 3 ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದರೆ you have to shift 2 points. So 1.78 into 10 to the power of 3. But when it comes to the 10 to the power of minus values ಅಂತ ಹೇಳಿದಾಗ, this method will help you in order to convert 10 to the power of minus 3 to 10 power minus 6, or minus 9, nano to micro, micro to nano, or nano to pico, and vice versa. This will become a easier method to follow. This avoids some kind of confusions what students will be usually having. So the final answer for this particular question is F equals 17.8 kilohertz. Clear? These are the simple problems, but here in this Hartley oscillator, L value is equal to L1 plus L2. First calculate the total L and substitute that final L value in the formula and calculate the frequency value like this. Clear? In the next session, let us deal with some more problems on this Hartley oscillator, and then we'll be moving with the next topic, that is the Colpitt's oscillator of the same LC oscillator. Clear? Thank you.